Hi, I'm Rachel, as the spoiler just let you know, and I'll be your host for this last session on this stage today. In my day job, though, I'm an engineering manager at Figma. I work with a team that just launched the new font picker and auto layout features, and we can't wait for y'all to play with them. Thank you, thank you. It is really cool to be here with you guys in person. Thank you so much for all attending. The vibes are so good. And thank you so much for everyone on our live stream. I've heard we have 50 Friends of Figma parties in cities all around the world, so thank you all too. Up next for this final talk in this room today, we have Ashley Seto, a lead product designer at Meta with a deep passion for color and design systems. Fun fact, you probably should never bet against Ashley in terms of color experimentation. Ashley's talk today will give us some details in the science of using color, some of the challenges of using color, and then will also give us some best practices for how to build accessible color palettes at scale. As a quick teaser, Ashley has some strong feelings about the color yellow, and I'm excited you'll also know why. I'm thrilled to welcome Ashley to the stage.
Hi, everyone. I'm Ashley Seto. Thank you for all being here today. I'm a lead product designer at Meta. Today, we're going to nerd out about color. We're going to go really deep on some of the fundamentals that make up color, how you should be thinking about color and using color within your design system. So let's start with where we are today in most instances of color within products. There are a lot of primitives or foundations within design systems, such as type, spacing, motion, elevation, corner radius, etc. Usually you're going to find designers staring at screens, trying to determine which blue is the most expressive blue for a brand, and picking out all the range of colors they want to use within their creative assets. This part of the process, we as designers are willing to spend thousands of hours on. I've been in plenty of discussions over the exact shade we should be using. We've ignored the fundamentals of this primitive. We hire specialists in more complicated primitives like motion and turn to type foundries when we need typefaces. But we haven't reached that point with color. Color is one of the most complicated primitives, is one we don't fully understand. While you can create your own typefaces, prototype motion, and play with different spacing, there are many nuances with color that make it one of the most challenging primitives to work with. Luckily, you're all with me today to learn about this primitive. I've spent a lot of time on it through 3 different design systems, building and crafting color palettes at scale. To start with, what even is color? Color is an expression of light, and we've barely touched on how to express color within our design systems. We don't responsibly apply color to our UI. Our technology today has a very specific way of displaying color, and that has to be taken into account when talking about color and how we use it. You may be surprised to learn that color expression isn't as straightforward as we were led to believe, where we're just waiting on the latest displays to display even more colors. For this talk, we're going to go really deep into some of the science behind color, how it is challenging for us to work with when we want to work with it, generating color dynamically, and about how to create accessible color palettes at scale that perform well for your product. For the sake of this talk, I'm going to assume you're somewhat familiar with using color in the tools that you have today and understand things like hue, saturation, and lightness, at least on a basic level. If not, I've included some of the terms here I will be using some of those terms at times where they may not be technically the exact term, but it helps, not to get too hung up on exact word choice. We will be focused on accessibility and color and how it affects accessibility. The standards I will be referring to are the WCAG standards, and generally considered the standards for digital products and what would be referred to in a legal case involving accessibility. The generally accepted level to hit is known as AA or AA, and we measure contrast with one color over another color, and for text, our goal is to hit a 4.5 to 1 contrast ratio, meaning that color over text, with text over a background, is hitting a 4.5 to 1 contrast. Inverting these colors does not change contrast. For example, black over white or white over black is a 21 to 1 contrast ratio, and that is the highest you can go. Okay, who here has a color palette in their system that was made by either yourself or another team? I think that would be everyone, unless you're working on a new product that literally has zero branding. I want you to think about how that color palette came into existence. What was the process your team used to get those colors? Did you pick the tints and shades yourself and spend a significant amount of time on each and every shade in that entire scale? Did you end up hiring a third party, like an agency, in order to create it for you? And then it was up to you to decide what you got back and how to basically use it. Who here then had to apply those colors to components? Did you also have to keep checking that they were meeting accessibility standards? You may have found that you had to use blue 300, green 400, yellow 800, and then red 500 in order to meet that 4.5 to 1 contrast ratio. Or maybe you haven't thought about accessibility at all, because in your system, the subtle colors are pleasing to look at. Why do we as designers not apply the same rigor and research to our primitives as we would to our product flows and how someone, uses a product? Why do those things differ? We are our own customers of this work as well. I'm going to walk you through a deep dive of my journey to understanding color, what I did along the way, and the mistakes that I made to get to where I am thus far, because it took me 3 times to get to where I am now. And hopefully for all of you, you can learn from my meanderings. I want you to think about where you currently are in this journey as I go through these examples. I think the first 2 tries were really just the exploration and research phase for the work that was about to follow. So try 1. I started my color journey in 2018, and I thought I was a genius. My color journey started with a humble badge and banner. I wanted to make these 2 components meet that 4.5 to 1 contrast ratio for accessibility. And the more I tried to solve this problem, the deeper and deeper I went into what was the endless depths of color. I wanted a yellow banner, and I wanted a yellow badge. Anyone who has worked with color, even at a basic level for accessibility, knows or maybe even hates the color yellow. It is the most challenging color in the entire palette in order to meet the required contrast. There is no such thing as a dark yellow that doesn't look like baby poop. And there are many ways that I could have fixed this problem. Some of you might have simply made the text black. But for the product I was working on, we were not using black text on colored backgrounds anywhere else, and that would have created an exception just for yellow. At first, I tried, of course, to use the yellow that I had. Like any good systems designer, you try not to break your own system. But it just didn't work, and there was no other option doing what I wanted it to do and meeting that accessibility standard. I decided I'll just redo the entire color palette. What a brilliant idea. I would solve the accessibility problems that I was having with an entirely new palette. How hard could it be? P.S. I still hate the color yellow. I approached this problem much like I would any other product design problem, and began with exploration and research. My explorations of color led to systems like Mineral UI and Lift that had begun this concept of what I called graphing color. This was a way to evenly distribute color, and I think I was drawn to the logic of what I felt was a very subjective primitive. I was graphing color in the HSL color space. And if you don't know what that means, I will be elaborating more on color spaces later, but it allowed me to focus more on the numbers behind the color rather than the color itself. This method of graphing worked, sort of. What I got was an even distribution of colors, but the distributions to solve for accessibility goals were different for every hue. And it was not a method that I could recommend to most people. One, it was extremely time-consuming. It could take me a whole day just to make a distribution I liked, and then those distributions then couldn't be reapplied to another hue. It was a tedious process, but one that started to teach me a lot about the properties of color and how contrast was working. Two, colors being evenly distributed didn't mean they had all the same characteristics in regards to accessibility. If you look at color palettes made this way, they suffer from usually the same problems I outlined earlier of manually picking colors. The values you need bounce around on the scale, making it hard for you to be able to use a consistent value. You could say, by the time I was done, I had used more of a brute force method in order to get even distribution to work. The entire project took me about a year because of how tedious it was, and because like most of you, my entire job was not to make a color palette. I learned a lot along the way. First, there was a point in every hue which a color could be perfectly accessible on pure black and pure white text. And second, that I could make a color palette that had colors that had relatively the same characteristics from an accessibility standpoint in the same area of the palette if I tried really, really hard. And third, as mentioned, it was really annoying to try and do this at scale. I solved what I needed to, and I thought I was a genius, like I'd cracked a code or a puzzle. But I was still pretty frustrated on how hard this was to do. I didn't ever really want to fuss with graphing color again. But of course, I couldn't put the problem down when I stumbled across another color palette that was not meeting any of my goals in regards to accessibility and for product application. I think we as systems designers are drawn to ever perfecting the craft of what we are working on. We see immediately what is not right for a design, and we need to fix it. We also need to fix it at scale, which is why we won't just stop at one iteration. This time would be different, because the first palette I created, I didn't care too much about dark mode. Ah yes, the dreaded dark mode. Every designer and every engineer in the audience who has ever worked on this problem is probably absolutely horrified at trying to tackle it, and for good reason. Dark mode is an entirely different beast than light mode. This time, I needed to create a palette that truly worked in both modes, and not just theoretically. I followed similar methods as the first time. I graphed the colors, and I fussed with them all over again, trying to wrestle this method into giving me the results that I needed for accessibility. But this time, I didn't just have one core color. I created two core colors, one for light mode and one for dark mode, that balanced in the middle of the scale. So why do this? I had already found out that I could make one color in the palette accessible in pure white and pure black. But accessibility in regards to contrast is not perfect. This is probably the first time I really started to dial in onto what was the human perception of color and noticing something wasn't working. Now, not just from a color space that I was using, but also from the intended application of the distribution of those colors. Now, this can all be attributed to what is known as Stevens' power law. Stevens' law states that there's an empirical relationship in the psychophysics between an increased intensity or strength in a physical stimulus and the perceived magnitude increase in the sensation created by the stimulus. And you may be asking yourself, what does that all mean? It means that our perception of anything that we experience in this world with our five senses isn't linear. That depending on what it is, we need more of that stimulus when it increases in order to notice a difference in that stimulus. This is super important when working with color. In the image on the left, the value is changing in equal amount per value in that column. The second column, though, feels more linear, even though the difference between the two values is increasing at a set exponential rate. We don't perceive lightness the way we think we might do. Remember this, because I'm going to come back to it. Okay, so now I've solved the problem. Or maybe not. Of course, solving this problem twice wasn't enough for me. When I joined Meta, I was met with the same problem, but with an entirely new set of constraints. What happens when you need to solve this problem for an infinite amount of colors, where the color palette is not a defined set, but whatever someone wants? Or what if that color is algorithmically selected? That was the problem facing me when I was developing a color algorithm. Our vision was to be able to take any image and to be able to theme an entire experience based on that image. That would involve not knowing the exact input, but needing to create an entire color palette from that one color and have it apply to all the components in the design system. A simple example might be what we have here, in which someone has uploaded a media of a flower, and we want that button to feel visually harmonious with the content. A more complex example might be our Facebook groups, where we could have a large variety of components, but they all need to be colored. This is something we're starting to see more in design, the blending of UI and content, whether that be through color extraction, like I'm doing here, or with things like materials with blurry, transparent overlays. I'm going to walk you through, first, choosing a new color space I decided to work in and why, coming up with the core color and developing a color algorithm, how I put accessibility first in everything I did, and a bit about applying color to components. The way we use color in design is changing, and choosing a color space will set the foundation for how you think about color within your system and the colors that you will have access to. In my previous explorations of color, I was working in the HSL color space. Now, there are many different color spaces, but a lot of people seem to gravitate towards this one, because it breaks down color into concepts that we can understand. Hue being thought of almost as the color itself, saturation being the intensity of that color, and lightness being how bright or dark that color is. In all my explorations, I found this color space to be extremely difficult to work in, and that's because the way HSL calculates lightness is flawed. Initially, there were explorations in which lightness determined the color value in a specific step in the palette. In HSL, lightness is not consistent with how we perceive it as humans, and thus lightness varied greatly from hue to hue. This, of course, is not an acceptable solution when applying color to UI. For example, if I was to choose the 50 lightness here in pink, green, and blue, you can see how different these colors are. The pink looks like it's the darkest color, while the green looks like it's the brightest, or at least I find it the hardest to read text over. If you're not a designer, you may not see the difference at all, which is why I included the contrast numbers below. If we were to try to evenly select those colors as well, we would not be meeting the accessibility standards. Here, when taking a look at where a 4.5 to 1 contrast ratio falls, we can really see that it falls all over the place. It is easy to produce a color palette in HSL just by picking the same lightness number, but then we've thrown accessibility out the window. Purple here falls very low on this even distribution, while green is very high up. And this may create a color palette in which you don't have all the values you need for the use cases that you have within your product. I needed to find another solution for the problem of infinite color. This is when I turned to perceptually uniform color spaces. Perceptually uniform color spaces attempt to model color in the way that humans perceive color. These color spaces are theoretically unbound, meaning limitless, and allow us to express color beyond what we're seeing today in the tools that we commonly use to design and create products. While you can design directly in RGB values, as an example, that's not true for the majority of perceptually uniform color spaces in the most common tools that we're using. This may be why a lot of designers haven't heard of the concept. The color space that I began to explore were the C color spaces, such as C-Lab and CLCH. C color spaces have more color than RGB, and that alone is huge. If you are working in RGB or HSL, you cannot write values for all the colors that are in the latest displays. Monitors such as Apple's P3 monitor offer more colors than RGB. We need these color spaces in order to take advantage of the new technology that we have today. I decided on CLCH, or LCH for short, because the way it was able to mirror a lot of similar concepts as HSL. In hue, we have a slight difference between HSL and LCH. It also had chroma, which is kind of similar to saturation, and it also had lightness, which is where that perceptual uniformity is mostly applied. While this is all very technical, and I'm not a color scientist, nor are the people that I work with, in order to have adoption of my work moving forward, people need to be able to have a baseline level of understanding of these concepts. And I found that this color space helped bridge the gap in that communication. Remember, design systems and parts of your design system need to be usable by the people around you. So now I have a color space that allows me to work in creating a color algorithm. But creating a color algorithm is not as simple as it may seem to those with a more technical background. Designers initially may not have any idea how to approach this problem. Like all algorithms, we have a responsibility to create ones that not only function well, but are, inclusive to everyone. And before everyone jumps on trying to create their own, let me break down some of the considerations. Starting from the beginning, so that everyone has an understanding of what I mean by color algorithm, essentially the algorithm that I created, how it worked, was to be able to choose from a set of colors from a photo. In this set of colors, I defined a series of cascading steps that decides what is the best color from this image. In practice, my day-to-day was very different than most designers who get to design color palettes. It was very different. We built custom tooling for me to be able to do my work in creating this color algorithm. And that tooling allowed me to upload an image, and it would display all the color options in that image, along with the LCH values and the percentage that that color was taking up within a photo. From this, I was able to write steps that prioritize what I deemed to be desirable colors. Colors that took up the majority of the photo, and colors that I found to be visually pleasing. It should feel like a designer looked at this photo and chose the most suitable color from that photo. The colors being in the LCH color space helped me do this because I was able to write logic that prioritized the prominence of the color by excluding colors that were too light or too dark. I had some engineers think that this task would be very simple. We have a photo here. We want a color from that photo. We should pick the color at the top of the list. I call these color algorithms dominant color algorithms because they only look for the most common color in a photo. In this specific instance, that might look like the solution. Blue is at the top, and we picked blue. However, if we were to take the most dominant color in this photo as an example, it would be black. Not exactly what most designers would have in mind, which is why dominant color doesn't truly work, because it could pick black. So you may concede to me that we could easily avoid picking black, because we're working in a color space that allows us to select color and section out colors for them being less desirable based on lightness. In this particular photo, the next amazing color you're left with is skin. No one I spoke to was too thrilled about the concept of fleshy buttons. Let me just say that again for effect. Fleshy buttons. While fleshy buttons might sound pretty disgusting, it could be offensive to people of color to have their experience of products taken over by their skin tone. I know I personally don't want my experience of the world presented to me this way. While you and your team might be soon jumping on the chance to create your own algorithm, consider the ethics of doing so. What I didn't show in the first image was the list of all the colors that I had to define and exclude to never be chosen. This was a huge range of skin tones from different ethnicities that allowed us to be able to responsibly use something like this within product in a way that is inclusive to everyone and doesn't make people's race part of the user experience. The future of color within our design systems should be inclusive. In everything that I'm doing, I'm putting accessibility first. Accessibility should not be considered an option for design systems and the people working on them. It is a requirement. Perceptual uniformity in color allows us to unlock consistency in accessibility and allows me to be able to meet the WCAG guidelines for compliance. We built internal tooling at Meta that allows me to generate color palettes based on contrast ratio that I'm looking for, the input of which I can get by manually entering in a hex value or through uploading an image through the color algorithm I created. This is important because unlike most tools out there that currently allow you to create color palettes, I can't go in and manually tweak every value. I mean, I could, but this isn't really how to do this effectively at scale. Taking a look at a few different examples of this, I want to point out where perceptually uniform color makes it easier for us to meet accessibility standards. The first line that we have here is the LCH value of the color. The first number is what we care about. That is the lightness number. Notice how they all came out to 49, give or take some after the decimal. I've included the contrast ratios below to white as the last bit of information. As it's not performant at scale to do this, there is a tiny variation in contrast ratio, which is why you're seeing that slight variation in the lightness value. Imagine how much easier this would be for us as designers to meet accessibility standards with one of the most common text colors, white. Comparing to my earlier HSL example, notice how the lightness value of each color feels. Now, I haven't normalized the chroma at the bottom in any way, so some of the colors might feel like they pop a bit, or you're not a designer in the audience and you honestly can't see the difference. Don't worry, none of my engineers have any idea what I'm rambling on about half the time. They just trust me and that what I'm saying is reality, so thank you to my engineering team for putting up with me. But we're seeing here the 50 lightness changing wildly in contrast in HSL, while roughly the 50 lightness having very consistent contrast ratio in LCH. This can be applied consistently to components within our design systems. It should be noted that not every color hue occupies the same sort of space, so there's a lot of checking when it comes to cases like yellow. But with the methods that I was talking about earlier, after checking those cases, you can be sure that any color someone wants to use will meet the appropriate contrast ratio. Your color palette cannot be crafted in a vacuum without use cases. The majority of color palettes out there have been crafted without consideration for how that color palette would be applied within product. Color palettes at scale are not just designed to look good, but are tweaked and created for moving product metrics. So you've made it to the point where you're hopefully sold on the methods, at least, that I'm using to create color palettes, and now you actually want to apply those colors to UI. The first question you might ask yourself is, how many steps do I need in my palette? And I think a lot of people would say 10. I usually ask, why 10? Where did 10 even come from? Is it because that it's a nice round number that we chose 10? The number of steps in your palette should be determined by the number of use cases that you have within your product and the particular brand goals that you have. Consider what the core brand color is for your product. Consider if potentially your brand color might not be doing all the jobs to be done for your particular components. Can you change this color in order to meet accessibility standards and create that perceptual uniformity? Do you want that brand color to be the same in light mode and dark mode versions of your product? Where does your brand color appear in product? And is it doing everything that you need it to do? These are some of the questions you should be asking yourself before starting on your palette. Look at the levels of elevation within your app. These should be the layers of UI that you have, such as your background, your main content layer, any modals, bottom sheets, or overlays of content that you have on top of everything. How many do you currently have? Figure out the colors needed to distinguish elevation before moving on to the other more fun colors in your palette. I know these colors tend to be some sort of grayscale or near grayscale of colors, And the reason that we need to think about these first is that color on top of color creates contrast. And you need to know what those base colors are, or at least roughly what they could be. When you have the foundation figured out, you're able to explore so much more. Our ability to control any color allows us to really dial in on how color boosts performance within the app. This matters. If you're a PM or engineer, or you're a designer working with a PM or engineer who says, so what? Why should I care about design putting in all this effort for a color palette? I have revenue to increase and product metrics to move, and you're super focused on moving that growth metric. Maybe even accessibility isn't a priority for you. Being able to create harmony with color, as I did through this color algorithm, allowed me to be able to change metrics within product. All tests run against someone choosing a color that was not our brand color versus the algorithm I created resulted in my algorithm performing better than anything else in the engagement metrics that we were tracking. While there are many examples of brand color being the best option for products, that isn't always true. In this example, all the color changes to Reels alone led to over a 2.5% increase in the ads metrics that we were tracking through intentional use of color and increased contrast of that color. Anything over 1% is huge at our scale. Higher contrast color also perform better than lower contrast color within a threshold. Just because 4.5 to 1 is the minimum that you need in order to hit accessibility doesn't mean that it is the best performing contrast for your product. I said I was going to come back to Stephen's power law. Being able to create hierarchy with color you can control the contrast of will allow you to change metrics in your product. All contrast is visual separation within UI. And we as designers know that hierarchy matters. We know we can make a button stand out from a page by making it red and making it the only red object on the page. Looking at these two images, can you spot the difference? I'll give everyone a few seconds. Don't worry, plenty of people can't. And this is where things get interesting, because a lot of people tell me they can't see the difference. In fact, people reviewing this deck couldn't see the difference and asked me if I made a mistake. But my data tells me that the one on the right with slightly higher contrast is performing better than the one on the left. We talk about how to measure color and, in this talk, but we also talk about measuring impact for design systems through all sorts of ways, through time saving, adoption, code quality, but really, this is the future of design systems. Being rigorous in all of the knowledge that we have on all parts of our system so we can affect product-wide change, which equals hitting core product goals. So what's next? There is still need for a designer's eye with all the updates to color spaces and calculating contrast. If I didn't already turn your mind to putty, there are even further complications with color. The biggest one you may run into next is what is known as the apnea effect. Essentially, when calculating contrast for hue, it can appear as though that hue is changing even when it isn't. This is where a designer's eye can still be used at this stage. You may think, for example, that the top row of colors here is the one that's changing from blue to purple. But actually it isn't. It's the same hue, and it's actually the bottom row of colors here that's changing hue in order to meet our visual perception of how we expect hue to change. This is the weakness of many color spaces. Be rigorous when making your color palettes. The requirement for accessibility is coming to digital products, and it is not a color talk that includes accessibility without a nod to WCAG 3.0. This is probably years off, and we'll finally have accessibility standards that more officially apply to the types of digital experiences that we're making today. The EU is adopting very similar standards to WCAG 2.1, and those are becoming mandatory June 28th, 2025. I told you all this would be a requirement. With mandatory accessibility, companies will be scrambling to be able to do this kind of work at scale and quickly. The only way, though, to get there easily is through being able to generate color palettes based on contrast, which will also be greatly helped with the consistent architecture that design systems offer. Look at what you have in your product today. Is your current color palette accessible? Can you make it accessible? Push for accessibility over branding. While I have personally chosen a specific color space to work in, it is not perfect. And I'm not sure there is a perfect color space. But there are consistently new and improved options coming out that have yet to be integrated into our tools. One I'm particularly excited about is OKLCH, which aims to correct perceptual uniformity in other areas of color and not just lightness. As we begin to push further and further into this area, we're going to see more and more ways to adopt these easily into our day-to-day work. While today, it's a huge struggle to even work in CLCH because most online tools are completely wrong with color conversions. More companies are adopting these less conventional color spaces. Find tools made by people that you trust to begin working in these color spaces and explore how contrast changes your product. Because the way we use color in design is changing. Are you going to change with it? Thank you.